How nervous are you?
I am very nervous actually. We don't know what's going to happen right now.
Are there really chances of something going wrong?
The electronics part is a bit of unreliable. Apart from that, everything is fine. So right now we are going to test, so let's see.
Yeah, and we have to be this far away from the motorcycle because safety reasons,
Because
the
of the
propellers, I mean,
If anything
1 in
goes
100
wrong.
chance they can break.
Yes.
And that'll be quite fatal because they'll just go flying in
That will
all
be good.
directions.
Yes, that will be very fatal.
Okay, the propellers are rotating. Yeah, he's gonna move away, Daksh. And now let's see if it lifts. They're gonna give it more throttle. Hi guys, I'm Abhinav. I'm at the NSUT Engineering College in Delhi today. Behind me is something very interesting. 3 kids that I've seen work at Speed Monks Performance Center over the last 1 year, ever since my Hero X-Pulse 230 was being built there. These kids have been working on their final year project at Speed Monks and here in their college. And it's something extremely innovative, extremely interesting. These kids are trying to make a motorcycle fly. They started off with a Kawasaki Ninja 250, a parallel twin 250cc motorcycle, but the engine was too weak for it to take flight. So they switched it up. They went with a Triumph Daytona engine. One of the guys over here, he cut up his own motorcycle. That's how passionate these kids are. And they have built something which we are going to go and take a look at now. Hello boys. So this is Siddhant. We have Daksh over here and Saurabh. We did not intend to make this video like this. We've been rehearsing for the last 4 hours now.
Almost.
Yeah, and then we ran into a little bit of a technical snag. Now these guys are trying to give it last minute finishes. They think they have solved the problem. You have, right?
I don't think so.
We thought we had
We need to work. Everything was fine, but there's some electrical issue right now.
Okay, so they've run into a little bit of an electrical issue, but that's all right. We can still discuss and tell you what this project is.
We named it Socorro, and this is a manned aerial vehicle. It can fly, it can lift a person's weight, and I guess that's all there is to it about it. For the overview, it's got a Triumph Daytona 625 engine.
But this is not a stock engine, right?
No, this is tuned by Bajaj over here, and this work was done by Speed Monks Performance Center.
Or you even have their logo here.
Yeah. And we got propeller over here, the controlling mechanism, transmission. We designed and developed the whole chassis of it. It's made of aerospace grade aluminium. And we have Arduino robotics control as well to control the propellers if we want to make it unmanned. But likely we'll be using it unmanned for the safety purposes, but it can also be driven if there's a rider hops on it. So it can work.
But
like
that's
that
all
as well.
theoretical because none of this has been tested so far.
Yeah. We have done few testing in which we actually took a flight. We did.
Yeah?
Yeah. So after that, it had an altitude of around 5 to 7 centimeters lift, and we just wanted to see if we can develop enough thrust for this whole machine to lift off. It was unmanned, certainly, and we are planning to increase the altitude even further right now.
This will take the weight of a full grown man.
Yeah. it
So
will.
I'm let's say close to 90 kilos. If I sit on it and if I can control it, or if you control it remotely,
Can
it
be
will
done.
theoretically take me in the
Yeah,
air.
It will. Theoretically, yeah. If it can lift off, let's say, if you apply some physics to it. So if there's a upward thrust after all the mass and gravity forces, if there's an upward thrust, final upward thrust, so it can go as far as we have air pressure and density.
Okay.
So altitude is not a problem, but we are just we have limited it because we are testing it. If something goes wrong, we just want to make it sure that it doesn't go very high. It can
Right.
go higher, but maybe we'll take it higher, maybe. But after when we are completely done with testing and we are satisfied, yes, this product
Okay.
is good.
So I see that, apart from the engine, you guys have a pretty trick trellis frame around it. Daksh, you want to come in and tell me a little bit about this 12 feet long beast that you've made?
So this is an aluminum trellis frame chassis that we've built around the engine. Why we choose aluminum is because aluminum is very light and it's very durable. It's a bit expensive, but there are no shortcuts here. You see, it's a 6351 grade aluminum. That's aerospace grades.
Okay.
So you see that it's quite a long chassis. There's back extensions which hold
Right,
the
to
rear
hold the propeller?
Propeller, yes. It's meshed. The meshing is done so that if in case of failure any shock is applied to it, it can be distributed so that no part breaks. You see?
Right. And so the way it extends at the rear, similarly it extends at the front here as well.
Yes.
Are the lengths equal or have they been calibrated and
Yes,
you
they
know?
have been calibrated a bit so that the center of mass falls exactly at the center of the bike.
Right. What exactly is the full weight of this entire unit?
The full weight of the bike is around 150 kgs and the chassis, the aluminum chassis weighs around 18 kilos.
Okay. And I see a lot of pulleys and belts over here. Could you tell me what's going on?
Yeah, you see that we have used a belt transmission to power the propellers.
Okay.
Why we chose belt? Because the plane of rotation offered by the engine is perpendicular to what we need at the propellers. You see, it's a quarter twist.
Yeah, correct. Because the wheel is like this.
Yeah.
But your propeller is like this.
Yes.
So this is where the switch happens?
Yes, this is the quarter twist belt because you cannot do it in chain or
Right.
other units. Like you could use a bevel, but that's very heavy and that's very expensive, you see.
Right. And this being a college project, you still have to, do it within certain means. Because
No.
this is privately funded. This is funded out of your own pockets.
That is the reason why we chose belts. You see, and this is a continental belt, so that is used in Harleys. You see, this is not like it's a very reliable thing. These belts they go one to the back and one to the front.
Right.
So that's because we need the 50-50 division of power because we need the bike to lift evenly
Okay.
from both ends.
All right. So let's say you achieve liftoff at what RPM?
Around 6,000 to 7,000 RPM.
And I think 6,000, 7,000 RPM, let's say the motorcycle would be making about 60, 70 horsepower.
Yeah.
So 35 would be going towards the rear and 35 would be going to the front propeller.
Yes.
Right.
This is our center shaft. It basically holds the driven, that's the driver. This is the driven,
Right.
this one.
Primary drive and secondary drive.
Secondary drive. So and later on this becomes the primary drive and this becomes the secondary drive.
Okay.
So you see that there is a lot of vibration in this area.
Okay.
So the meshing over here
Right.
is done so that there is no vibration, and aluminum
Okay.
absorbs most of the vibrations in this. So the trellis frame is actually quite useful here.
Okay. Now, well, we've seen the engine, we've seen the trellis frame, but ultimately it's the propellers that lift the motorcycle up. Saurabh, hello. Can you tell us a little bit about these propellers?
These are basically tri-blade wooden propeller,
Tri-blade meaning three
three
blades.
specially handcrafted from beechwood.
Handcrafted.
Yeah.
Where did you get them handcrafted?
So we came across a person in Punjab. There are only few people who handcraft them in India.
Okay.
So it was a bit tough to find, but in the end we.
You were telling me that earlier you experimented with smaller propellers,
Yeah.
right?
So we have done many calculations and research and about the propellers. We started off with a way much smaller prop. We didn't have any reference on the internet on what size to use and what kind of thrust that prop will be producing. We tried 7 or 8 props and we damaged few, and after that we finalized this size which is capable of lifting a human being.
Right. Now you were telling me about something known as swash plates, right?
Yeah, swash plate.
What exactly is a swash plate and why are you using it?
So it's basically a device which helps us basically change the angle of the propeller. Angle of the propeller, like Siddhant is showing right now,
Okay.
while the prop is rotating
Okay.
simultaneously. So what happens is this is a fixed pitch propeller.
Okay.
What does it means? Basically the blades are fixed and it cannot we cannot change the angle
The pitch of it on
Yeah.
its own.
Yeah. So what the swash plate does is it changes the plane of the propeller.
Right.
Yeah, without changing the pitch of the blades.
Okay.
Yeah. So we
Okay.
have custom made. We redesigned the conventional swash plate which are used in helicopters right now, and we manufactured and customized it according to our own needs, according
Okay.
to this fixed propeller.
So basically, what this wash plate, I'm a layman, so
Yeah.
in very simple words, it will help you stabilize the craft in the air, right?
Yeah, same time.
And then control the flight path also.
Yeah, we can maneuver in the air while the props are rotating.
You guys were aiming for a 4-month deadline.
Yeah, initially we were pretty naive when we initiated this. Like first month, we'll get a bike, we'll dismantle the engine, do the transmission for second month. Third month we'll develop the whole chassis, and fourth month like assemble the propeller and everything to one place, and let's finalize the product and start testing and stuff. But it took us more than 1.5 years now, and we are still struggling somewhere.
And the big reveal happens in 4 days, right?
Yeah.
On Thursday.
Like we
Today
have
is Sunday.
We have 4 days for 24th on which we're planning to reveal it. We'll be able to do it.
Okay, now tell me this, when you started this project initially, what kind of budgeting did you guys have in mind?
So we thought we'll end up investing around 3 to 4 lakhs.
Okay,
Yeah, but that was the cost which we spent only for our research and all the testing and everything which broke, changed, so all that stuff. So now we have almost invested around 14 or 15 odd lakhs,
My God.
including the bike's engine. Yeah.
could you give me a little overview of the controls? What exactly is happening over here? I see a lot of,
Yeah.
switchboards and all.
So this is a DC converter which gives the output voltage as per the servo motors over there.
Okay.
And this is a wireless, and this is a microcontroller which has a connection. They have a communication together,
Okay.
which makes it feasible to make it wireless and unmanned. Right. So how it goes is this is for the yaw motion, this propeller. So
Okay.
if we rotate this one, so
Right.
this wash plate goes left and right.
Right.
And this is for the forward motion.
Okay,
If we go like this, so we have a horizontal component which goes in this direction,
right.
including a vertical component. This will facilitate the weight of the whole machine, including a person, and this will take it forward.
Okay.
So basic physics and geometry over here. And for the throttle, so these are the plastic gears. So this is again a servo motor meshed with a throttle, and this is OEM throttle over here. But again, no such changes which cannot go back. So
So you are remotely controlling the throttle.
yeah, see, if I rotate this potentiometer,
Right.
it gives it more gas. So that's
All right.
how we're gonna control the RPM and engine power. So everything is controlled. But again, yeah, we are facing some issues in the electronics as of now.
That's all right. It's just, it's a project. These things, many things can go wrong. And the fact that you guys have been able to reach this far is commendable. Now tell me something. How exactly does it fly?
Propeller RPM around like 4,000 each.
Okay,
And that is the point where this whole machine lifts off.
okay. And the propellers, they rotate in opposite directions?
Yeah. So to counteract the torque, the counter torque, we have to rotate these two propellers at different, like clockwise and CC counterclockwise.
Right.
So this is a pusher one, this is a puller one. If you rotate them in opposite direction, they'll give the final force in one direction, that is upward in our case.
Okay.
Yeah. So that's all. Okay, there was more to it. Like everyone knows, not everyone. Those who are, those who know stuff about these big bikes. So this is a ram intake machine, right?
Right.
So it needs to suck air.
Right.
Like rather instead of sucking air, we need to provide it with the airflow
Okay.
for the right amount of oxygen, or it will lose power, right? So there was we had some desperate attempt for this as well. So these things over there. Could you
Yeah,
please
that's
show?
what I wanted to ask.
Yeah. So this is nothing but a centrifugal blower.
Okay.
And we have extended it with a hose pipe over here.
Okay.
And this directly goes into the airbox. It is like a substitute to a turbo,
Right.
because adding a turbo needs to change the manifolds, pressure and everything
Right.
of the bike. But I didn't want to do that. So this rotates, this gives the essence of a like direct ram air intake
Right,
to the Daytona
right.
engine. So
In essence, it's just sucking in air and providing more air
yeah,
to
we are-
the
we are facilitating
engine.
it
Right,
like a-
right.
yeah.
Just like ram air.
Yeah, just like a ram air.
Right. And these shields are to protect the rider.
Okay, so this is again very heavy material science applied to it. This is polycarbonate Lextech. So
Yeah.
this is such a tough compound. It's not exactly lightweight, but like we wanted it to be transparent so rider can see the propeller when he's riding it.
Right.
And this is supposed to be like very tough, right? So we have tried hammering it. It broke the weld, but this didn't break.
Wow.
It's actually bulletproof if you increase
Yeah,
the
this is
thickness.
called bulletproof material.
Oh wow.
If you increase the thickness, it is actually bulletproof.
Okay, and your project is called Socorro.
Yeah. So
What does that mean?
Socorro is a Latin word, Portuguese Latin word, like something of that sort. So it means help. So it's like immediate aid to some problem, some like when there's some emergency situation, right? So for the emergency situation, ambulance takes time. Everything like there's a time factor which is in the situation. So the whole motive to create this project was to reach to the people,
Right.
to reach the person in need at right time,
Okay.
as fast as we can. So that was the whole point. Like someone, it can be used in transportation, medical, defense, and like we had those things. But yeah, we'll be discussing it later on maybe. Or
Clearly, it's not quite there, but it's a step in the right
yeah,
direction.
this is a foundation which can lead to like further improvement. Lots of improvisation, lots of
True.
research.
True.
Honestly, because guys don't have that much funds and we have to move ahead also, right?
Of course.
So like it's already like I guess more than half a year now we have passed out from the like we have graduated and we are still on it for 6 months at least. So now you guys have further plans. So we just want people to know something like this can be done. We could have shown it as a concept, this thing can be done, but again that's not fun. So we created a prototype which actually works. It can lift off, it can take a person. So yeah.
Okay, so what do you boys think? Are we going to have liftoff today?
Unfortunately, not.
I'm afraid.
No?
No.
We're
There's
actually stuck in snarl.
There's some issue with the battery or something.
Okay, no worries.
It will take some time to figure out what the problem is, but eventually by tomorrow, I think we can overcome this. Yeah.
They're disappointed right now, which is understandable, but I mean, they're trying, that is what matters. If you're never going to try, you stand zero chances of winning. All right, that's all for me for the day. Bye bye.